Morning everybody. Today I am going to explain about quantum numbers. Quantum numbers gives the exact location of the electron or address of the electron. It tells about the information of the electron, where the electron is actually lying. We have four quantum numbers. One is a principal quantum number, and other one is azimuthal quantum number. Another one is magnetic quantum number. Next one is spin quantum number. Coming to the principal quantum number, it was discovered by Niels Bohr. It is denoted by n. N value starts from 1 to infinity. It gives the information about shells. If n is equal to 1, it lies in K shell. If n is equal to 2, it lies in L shell. It gives the information about the location of electron in which shell. Coming to azimuthal quantum number. Azimuthal quantum number is also known as angular momentum quantum number. It was invented by Arnold Sommerfeld. It is denoted by L, and L value starts from 0 to n minus 1. It gives idea about subshells. Magnetic quantum number, which was invented by Landé. It is denoted by ml. It gives the value of number of subshells, and number of electrons. The formula is 2l plus 1 for finding number of subshells, number of electrons 2 into 2l plus 1. Spin quantum number was discovered by Uhlenbeck and Gauss-Schmidt. It says whether the electron is in clockwise direction or anti-clockwise direction. It represents like this. Whether they are moving in clockwise or anti-clockwise. In this class, I am going to tell you very clearly about the mathematical analysis of quantum numbers. If n is equal to 1, this is about quantum number value. Shells. If n is equal to 1, we know that it belongs to K shell. Then L value will be L is equal to n minus 1. 1 minus 1, it is 0. Then which orbital? It is going to occupy which orbital? It is going to occupy s orbital. Shape of s orbital is spherical shape. And here, if n is equal to 1, it is 1s2. S orbital can accommodate maximum of 2 electrons. It is given by 2l plus 1. 2 into L is 0 plus 1 is equal to 1. That means number of degenerate orbitals. Is 1. Orbitals having same energy levels are called degenerate orbitals. Number of degenerate orbitals is given by magnetic quantum number. Then number of electrons is given by formula 2 into 2l plus 1. Already we calculated 2l plus 1. 2l plus 1 is nothing but 1. So 2 into 1 is nothing but 2. So n is equal to 1. The address of the electron, it belongs to K shell, and the L value is 0. The number of degenerate orbitals is 1. Number of electrons is 2. That means s orbital can accommodate 2 electrons, and here the configuration will be like 1s2. Then coming to n is equal to 2. If n is equal to 2, it belongs to L shell. The value of L is same, n minus 1. So 2 minus 1, it is 1. So if L is equal to 1, then we have p orbital. P orbital is dumbbell in shape. P orbital is dumbbell in shape, and here the configurations will be like 2s, 2p. Here we have 1s, 2s, 2p. And here in the above case ml value is 0. And here 2l plus 1 is nothing but 2 into 1 plus 1, 3. So number of degenerate orbitals that p can accommodate are 3. We regard it as px, py, pz. So these are called degenerate orbitals. In px there will be 1 electron, in py there will be 1 electron, pz there will be 1 electron. After a detailed discussion of magnetic quantum number, we will come to a conclusion that if we have half-filled configuration, then these orbitals are called degenerate orbitals. Then number of electrons is 2 into 2l plus 1, 2 into 3 is nothing but 6. If L is equal to 1, then it will be p orbital. P orbital can accommodate 6 electrons. S orbital can accommodate 2 electrons. By this it is very clear that in n is equal to 2 we have 2s, 2p. S can accommodate 2 electrons. P can accommodate 6 electrons. So total electrons 2s and 2p can accommodate is 8 electrons. Niels Bohr has given a formula to find out number of electrons. It is 2n square. If we calculate that, we can get how many number of electrons are accommodated in if n is equal to 2. It is 2 into 2 square. 2 square is nothing but 4, 8. So 2s means 2 electrons, p means 6 electrons, 2 plus 6 nothing but 8 electrons. I have to tell you what, if L is equal to 1, then the magnetic quantum number gives the idea about number of electrons in a particular p orbit. But Niels Bohr has given a clear idea about number of electrons. Please don't get confused there. Then if n is equal to 3, then it belongs to M shell. L is equal to 3 minus 1. L is equal to 2. L is equal to 2 means a d orbital. D orbital is nothing but double dumbbell shape. Here 3s, 3p, 3d. Let us see how many degenerate orbitals are present in D. 2 into 2 plus 1, 5. So d orbital can accommodate 5 electrons. Then we say that d orbital is half-filled and d orbital has degenerate electrons. It is a half-filled configuration. Then number of electrons d orbital can accommodate is 10. Total number of electrons, that if n is equal to 3 means 3s means 2, p means 6, 2 plus 6 8, then d means 18. If n is equal to 3, the total number of electrons are 18. Now coming to the next point, n is equal to 4, then it is n shell, then L is equal to 4 minus 1, 3, f orbital. We cannot know, we did not know the exact shape of f orbital. And here 4s, 4p, 4d, 4f. It can accommodate 2 into 3 plus 1, 7. Number of electrons 2 into 7 is 14. F orbital can accommodate 14 electrons. If you want to calculate total number of electrons, S means 2, P means 6, 2 plus 6, 8, D means 10, 18, 18 plus 14, 32. 32 electrons, if N is equal to 4, it can accommodate. And I want to tell you, 5 degenerate orbitals are nothing but dxy, dxz, dyz, dx square, y square, dz square. And this is about the entire analysis of quantum numbers in analyzing the configurations. I will say you very clearly that if n is equal to 1, then 2 electrons. If n is equal to 2, then 8 electrons. N is equal to 3, 18 electrons. Then n is equal to 4. Total we have 2 plus 6, 8. 8 plus 10, 18. 18 plus 14, 32. So 2, 8, 18, 32. These are the electrons present in the orbitals. Hence, all the quantum number gives the idea about the address of the electron in my terminology. Thank you.